Hello everyone, we are Group 3 and we will be showing you what a transform fault is. Now, what is a transform fault? Well, in simple terms, imagine the Earth's crust like a giant puzzle. Sometimes, the pieces will slide past each other. A transform fault is where two pieces of the Earth's crust, which are the tectonic plates, slide side by side together horizontally. Sort of like when you rub your hands together. This sliding of land can cause earthquakes because the land often gets stuck while moving and then released suddenly, which creates these faults. Now, you may be asking, how does the earth move when its ground is so hard? Well, to put it simply, the earth has layers on it, and these layers basically work together to help the uppermost layer move. Now, what are the layers that helps the upper layer move?
The lithosphere is like the Earth's outer shell. It's made of solid rock and it includes the crust and the very top of the mantle. Think of it like a hard chocolate coating on an ice cream bar. It is also a massive and hard solid substratum holding the semi-solid liquid, biotic, and gaseous molecules and masses surrounding it. All geomorphic happens on this sphere. Geomorphic process means bringing about changes in the configuration of the Earth's surface due to physical stresses and chemical actions on the materials present on Earth. That's why when nag-start na ang transformation fault boundary, ang una mabuwag ang lithosphere, then so on so forth. The reason behind it is the lithosphere is hard, but it's also the thinnest. Based on the statement, it's because that it is a massive hard solid substratum holding the semi-solid liquid, biotic and gaseous molecules and masses surrounding it. The reasoning of it na it could easily crack is because daghan gi-carry ang lithosphere.
The stenosphere is a layer found deep within the Earth, around 100 to 250 kilometers below the surface. Unlike the rigid, solid layer above it, the lithosphere, the stenosphere is more flexible and behaves like a thick, slow-moving fluid. This softness allows the Earth's tectonic plates, which rest on top of the stenosphere, to move aside. These movements are what cause earthquakes, volcanic eruptions, and the formation of mountains. The stenosphere also plays a key role in the Earth's eternal heat circulation, helping to move heat from deeper within the planet up towards the surface. This process drives the slow but constant shifting of tectonic plates over millions of years.
The mesosphere is a sphere deeper inside to the Earth, and one of the hottest since it's closest to the Earth's core. But although it has more solidness than the asthenosphere, it doesn't have as much movement or as much solidness as the lithosphere. And why? It is because of the pressure of the Earth and the heat, which would allow the lithosphere to have more movement to move its tectonic plates. Like, think of the mesosphere as like a thick ice cream. A thick ice cream that is inside a bar. And the reason for why its texture is like that is because of the Earth's pressure and the heat's pressure. But it's not as solid as the lithosphere, so that it could have more movement into moving its tectonic plates. Otherwise, if it's gonna be more solid, then it won't move. The lithosphere is unable to move its tectonic plates.
And this is exactly. So the lithosphere is yellow. The lithosphere is the hard outer layer, outer shell. And then the lithosphere is red. It's the layer of the Earth just below the lithosphere, which is this yellow. See? It's made of rock, but unlike the lithosphere, it's hard. But it has a soft and slow feeling side, you know. And then this is the mesosphere, the last. The mesosphere is a layer deep inside the Earth, located between the asthenosphere, part of the mantle, but
It's more solid and it's rigid than the layers above.
All these layers basically work together to make the upper part move. And with the help of all these layers, the lithosphere is able to make such beautiful yet such destructive formations.